Do you ever wish you could watch a fault evolve? Well, now you can. Using a custom stepper motor machine and Kaolin, we can watch faults evolve. We can map the evolution using two methods. Shear strain, which maps where the majority of shear is focused, and kinematic efficiency, which basically calculates how much of the shear strain is being expressed as slip on faults. For this experiment, the boundary conditions are pre-cut, meaning a fault is pre-cut using a thin metal probe that is electrified to reduce puckering of the clay. Local, meaning that the basal shear is localized. This is accomplished by placing the base plates directly next to each other. And deep, meaning a clay thickness of 5 centimeters. Let's look at a time-lapse of the clay with red and black sand and vertical impressions for visual clarity. Stage 0, distributed shear. Although there is a pre-cut fault, there is initial strength resulting in distributed shear during the beginning of the experiment. Stage 1, stress overcomes initial strength, fault begins to slip. Here we can see the shear strain, which is the blue and red, overlain on the time-lapse of the clay. Notice that there is no stage 2 in pre-cut experiments as echelon faults do not form. Stage 3. Fault reaches residual strength, meaning the slip rate is constant and the fault has stopped weakening. Now let's take a look at the kinematic efficiency alongside the shear strain. Stage 0. Distributed shear, 0% KE. Stage 1. Fault begins to slip, KE increases to about 70%. Stage 3. Fault reaches residual strength, KE levels off around 90%.